Hi folks, welcome back to Physics with Captain Rod. The purpose of this video is to talk about what's called the dot product. And what we're looking at here, we've got a pair of vectors, a vector A, and then here's another vector, vector B. There's some sort of angle between them. And vector A, we can think about it in component form, and I want to think about breaking vector A down into a component that is parallel to B and then a component perpendicular to B. So if we do that, I'm going to do these in red. Here's the component perpendicular to B. And here's the component parallel to B. So if I was to give this a guy name, I'm going to call this A parallel. Whoops. And the parallel means parallel to B. This is what I'm going to call A perpendicular because it makes a right angle to B. So this thing right here is called the projection of A onto B, and what it gives you is how much of vector A is in the direction of B. And you can find that quite easily by the cosine function. This is a right angle. The magnitude of that triangle is whatever the magnitude of A is, or that's what the hypotenuse would be. So this projection here, because it's adjacent to the angle theta, it's equal to magnitude of A cosine of the angle theta. So again, this is called the projection of A onto vector B. Now, in physics, there's lots of examples where we need the component of one vector in the direction of another, and then these need to be multiplied, and that's what the dot product is. If I write it out, it's A dot B, and that actually reads dot, as opposed to another type of vector operation called a cross product. Right? I'm going to save that for another video, but that reads A dot B is equal to, it's the projection of A times vector B. So by the time we multiply that out, what we get is magnitude of A, magnitude of B, cosine of the angle between them. And again, A cosine theta is giving the projection of A onto B. Now you could also think of it as the projection of B onto A, and then multiplying by A. It doesn't really matter which way you think of it. An example of where you would use this in physics, when you calculate work, that ends up being a dot product. It's the force vector dotted with the displacement vector. Or in physics 2, when we talk about potential difference between 2 points, that comes from the electric field vector dotted with a change in position vector, and there's lots of other examples. But anyway, that's how a dot product is calculated. Now, this is how you would typically calculate a dot product when you have a magnitude and angles. We can also calculate a dot product in unit vector form. So if I have a vector A, and I'm going to keep this to just 2 dimensions here, which looks like AXI, meaning an x component I direction, plus AYJ, meaning a y component j direction. I take another vector, B, which can be written BXI, plus BYJ. If we go ahead and write the dot product out in component form, and I'm going to go ahead and do that, A dot B, that's going to be AXI plus AYJ dotted with BXI plus BYJ. Now, when we do this, you can just do this basically like foiling it. That first term right here is AX BX I dot I. Now, if you think about dotting I and I, these are the same vector. Angle between them is 0. So that's going to be, if I were to take, imagine this is an I dot I, and remember that the magnitude of I is 1. So that's going to be 1 times the cosine of 0, which is 1. So this product, AXI, dotted with BXI is 1. Boom. The outer product here is going to be AXBY. Now, if I write this out, we have I dot J. I'm going to write that one out, I dot J. If you think about dotting this pair here, I dot J would be magnitude of I, which is 1, magnitude of J, which is 1, cosine of the angle between them. The angle between them is 90, and the cosine of 90 is 0. So this term right here is 0. In fact, the J dot I term also going to give us 0. So I'll go ahead and write that out though. AY BX J dot I. But again, That thing right there is 0. And the very last term, ayj dot byj, that's going to give us ayby, and again, j dot j is 1, similar to the I dot I. So this ends up equaling just axbx plus ayby. Now I did this in 2 dimensions just to keep it kind of short, but if this had an azk and a bzk, you would just have another term here, azbz. So that's what a dot product is. It's the projection of one vector onto another, and then it multiplies them. So in this case, it would be, if I take a dot b, we're taking this red length and multiplying it by b. It would give you the same thing as b dot a. This is how it's calculated: magnitude of a, magnitude of b, cosine of the angle between them. Or if we have these vectors in unit vector form, a dot b is axbx plus ayby plus, if there's third components, azbz. So I hope this video at least gives you a reasonable overview of the dot product and how it's calculated. I think I'll save the examples for another video. Have a great day.